In this video, I want to have a look at expectations. So we can calculate the number of times we expect an outcome to occur by multiplying the theoretical probability of that outcome by the number of trials. So for example, if we have a die and we roll it 270 times, how many times would we expect a 4 to come up? So we know that the probability of rolling a 4 on a die is 1 in 6. So that means we can figure out the expectation by going that 1 in 6 times 270. So 1 over 6 times 270, and that would give us 45. So we would expect to roll a 4, theoretically 45 times. More specifically, we can calculate the financial expectation of a game. So that's going to tell us the expected return. And obviously, each game is going to vary whether you win money or lose money, but the financial expectation tells us the average. So if you were to play this game thousands and thousands of times and average out your wins and losses, that's our financial expectation. So our first example says Nathan plays a game where the probability of winning $100 is 0.15 and the probability of losing $20 is 0.85, and we're asked to calculate his financial expectation. Now, the first thing to notice is that because the probability of winning is 0.15 and the probability of losing is 0.85, they're our only options. All right, so probability of winning $100 is 0.15, so we're going to go the probability of that times the outcome. And the probability of losing $20 is 0.85. So because we're losing money, we're going to subtract instead. And we're going to go 0.85 times 20. And that's going to come out to give us -2. So his financial expectation is a loss of $2. So some games you'll win $100, some games you'll lose 20, but on average, if he played it thousands and thousands of times, he'd end up losing $2 every game. In our last example, we've got a game where there's a 0.01% chance of winning $5,000, a 0.4% chance of winning $200, and a 25% chance of winning $5. So part A asks us to calculate the financial expectation. So part A. So we're going to go the probability of each outcome multiplied by the outcome. So 0.1% is the same as 0.0001 times 5,000 plus a 0.4% chance, so 0.004 of winning $200, and 25% chance, so 0.25, of winning $5. Now, if you put all of that in your calculator, you're going to come out with $2.55. So a financial expectation of $2.55. Part B, though, tells us that each game costs $3. On average, should a player expect a gain or a loss? So this $2.55 tells us that's on average what they're going to win each game, or their financial expectation every game. But if each game costs $3, then because we're not winning as much as we're paying to play the game, we're actually going to end up losing 45 cents each game on average. So just to clarify, we'd go 3 minus the $2.55 would give us the 45 cents. So a loss of 45 cents each game. Okay, so those are a few examples of financial expectations.